Hey guys, today we're going to solve quite an interesting problem on a DFA. Part of this is me just trying to hone in my skills in this because I'm currently taking theory of computation, and this concept is a little bit challenging, but it's like math. So it's one of those things whereby the more practice you take on it, the better you become at it, and the better for you to basically see these edge cases and be able to draw it out together. So, draw it out correctly. So, here, our language is all strings over the alphabet of A and B. And the conditions that we have is if a string starts with A, it has an odd number of B's. So, and if a string starts with B, it has an even number of A's. So here, this is more like a parity problem. So, and also there's two conditions that have to be met. So it's basically like an or problem. So we'll have a string that has to start with A and has to start with B. So what does this tell us right off the bat? It tells us that the empty string is non-accepting. Non-accepting. All right. So how do we do that? So we'll have a arrow going from nowhere coming into Q0. Forgive my drawings there. Let's actually make it perfect. We could, perfect. So just long press the ink pen on Windows and it basically creates that for you. Okay. So now we know that Q0 is non-accepting. So now we'll read an A. So the OR basically means that the Q0 is like a router. So this is like a router state because it'll go two ways. It can either go in A or B, and then there's two different conditions for both. So if it goes in A, let's go up. So this is A. So the first state, let's call this Q1. What was the condition again? It has to have an odd number of B's. So here at this point, the B count equals 0. So this is non-accepting. So we'll have to read a B for it to be accepting. So we try to find the base case. Okay, so now we'll have to read another B. I mean the first B. Okay? So now this state is called Q2. Okay? So in this state, what's our count of B? B equals 1. Perfect. What does this tell us? So the B count, the parity of B is 1. That means the parity of B is odd. So Q2 in this case will be accepting. So let's circle that with green. All right, there. So that's our accepting state. Perfect. And now let's check the other edge cases. So if we're in this Q1 state where B is 0 and we read another A, that doesn't change the parity of B, so it'll just self-loop to itself. So if we read another A, we just self-loop to itself. And if we read an A here, it doesn't change the parity of B, so we'll just self-loop to ourselves as well. Perfect. So the only case that we haven't checked is what if we read another B from here? That changes the parity because 1 plus 1, that equals 2. So if you mod it with 2, that changes the remainder to 0. So that basically takes us back to Q1. That's with the B. So this upper branch basically handles the cases whereby the B's is odds and B's is evens. So if we read 2 B's, we would go back to Q1. If we read another B, we go back to Q2. Okay? And for our second part of the branch, so we go B. Perfect. So this is Q3. At this state, the counts of A equals 0. So what does that tell us? A is already even, so this should be accepting. So just double circle it like that. Perfect. Okay. Um, but when we're so this is accepting, but what in the case whereby we go to another A? So that changes the parity of A. And in this case, we cannot really cross over branches because they have two different conditions. So if we cross over branches, we're always going to get an edge case whereby we will accept a string that we don't want to accept. So from here, if we see an A, we jump over to another state. And this state is called Q4. Let me write that better. And this state is called Q4. And we'll draw a nice little circle right there. So here, the parity of A is 1, and it wants us to have an even number of A's, so at this state, this is not accepted. But what happens if we read another A? If we read another A, that changes the parity back to even, so that should go back to Q3, and that will make our parity back to accepting. And so now let's check the cases of whereby B happens. So if we read another B while we're in Q3, that doesn't change the parity of A, so that should just self-flip to Q3. So this is while we were just reading B. And while we're in Q4 and read another B, similarly, the parity of A doesn't change. So that's with another B. And there we have it. That's our DFA that basically checks for these two conditions and makes sure that that is the case. Okay? So let's test it with a string whereby we have BB, AA, AA. Theoretically speaking, this should be accepted because we have the A count equals 4. So this should accept. Okay? So let's walk through how our our automaton will read through this. So you have B, we go to Q3, and then B, we loop back to Q3, and then we go to A, go to Q4, and then we have another A, go back to Q3, and then we have another B, we loop around Q3, another B, we loop around Q3, and we go another A, go to Q4, and then we go another A, we go back to Q3. So we end up in an accepting state. So yes, so this truthfully so will be accepted. All right, there we have it. So this is our state machines, and thank you for watching my video.